Section 4.3 Interactive Assignment. Objective 2. The time it takes for a planet to complete its orbit around a particular star is called the planet's sidereal year. The sidereal year of a planet is related to the distance the planet is from the star. Now, the accompanying data show the distances of the planets from a particular star and their sidereal years. We're going to use the data to answer parts A and B below. So first thing we're going to do is we'll click on the icon to view the data table. Before we do that, it says find the least squares regression line treating distance from the star as the explanatory variable. We want to be able to save the residuals and then plot the residuals against the explanatory variable, the distance from the star. So we're going to go ahead and first open up this information. So we're going to go ahead and select Open Up in StatCrunch. Okay, so here is our data. So let me go ahead and open that up. Okay, now what we want to do is we want to first determine, okay, the residuals. In order to do that, we're going to go to Stat and then go to Regression and then select Simple Linear. Okay, so the x variable is going to be the distance from the star, which is x in millions of miles. The y variable is going to be the sidereal year, which is y. Okay, and then we're going to scroll down a little further, and then what we want to do is we want to make sure that we want to have the residuals versus the x values, excuse me. And so that's what we want to select in the graphs. And then you see where it says save, we want to save the residuals, so it'll create a new column for residuals. Okay, so now let's go ahead and then select compute. Okay, so here we can see what the information is given us. Okay, it gives us the linear correlation coefficient of 0.98. It gives us the coefficient of determination. Okay, and we also have our line here. But what we want to do is we want to figure out, okay, which one of these graphs is this going to represent? So in our right arrow, we're going to select that. And so we can see here that we have this particular shape here of our residuals versus the distance from the star. And if you look at A, this resembles A. If we look at B, this is an upside down U. This is a U. And then if we look at C, then it doesn't match. So that's how we determine the graph of this, is by following that procedure. Now it says, based on the residual plot, do you believe the least squares regression line is a good model for describing the relation between distance from the star and the sidereal year? Well, before we do that, let's first of all check any outliers. So if we want to check any outliers, we're going to close out of this. And in order to check the outliers, we're going to need the column that we've already saved under the residuals. So we're going to create a box plot and determine if there's any outliers. So we're going to go to Graph and then go to Box Plot. We're going to select the residuals that we have. We want to make sure we use fences to identify any outliers. We're going to draw the boxes horizontally. Okay, and then we're going to go ahead and then select Compute. So when we look at this box plot, okay, we do not see any outliers located here on the box plot. So what does that tell us? Well, that tells us that the residual plot, okay, in this case here, when we look at this particular graph, it shows a U-shape. Okay, so it's asking us if we believe that the least squares regression line is a good model. Well, the answer would be no, because the residual plot above shows a discernible pattern. It shows a U. It doesn't give us a nice shape of a line of what we've seen before. So therefore, this is considered not a good model for this particular least squares regression line.